Hi, I'm Dhanraj Zadav. I'm from Team Sacredgeeks, and our problem ID is 3. Our problem statement is build a rack that answers the question using textbook knowledge base and returns a verifiable reference, that is section and page number. This is the flowchart we have implemented till now, in which the first problem which we have identified is how to handle such a massive file that is more than 700 pages, and how to add a feature of citation to our rack system. So the PDF provided by you guys is a PDF format that is not too system friendly or program friendly. So to make the content system or program friendly, first we converted the PDF file to a markdown file in which we have preserved all the headers and the headings, including the section numbers and section names, to generate the efficient chunks, such that we get the final answer with the citation. We have implemented parent child chunking method, in which first we have generated the parent chunk from the headers or from the splitters which we included in our markdown file, and then we generated smaller child chunks from the individual parent chunks, linked that child chunks to the parent chunk, stored the child chunks in our by embedding them using BGEM3 embedding model, which we have run locally, and stored the parent chunks as it is in our local file storage. So that is our ingestion pipeline, which mostly includes mainly two steps: converting the PDF file into a markdown file, and then generating the parent child chunking method, efficiently mapping them and storing in our system. This is our retrieval pipeline which we have implemented. And for retrieval we have implemented the hybrid search and re-ranker, in which for the in hybrid search we have implemented the vector search and BM25 keyword search. For vector search we have implemented the hide methodology, that is hypothetical document embedding. First of all, we have generated a pseudo response from the LLM, and then we embedded that hypothetical document using BGM3 local embedding model, the same model which we have used earlier for making the embeddings, and did a semantic vector search. And also parallelly we have also done a BM25 keyword search on the original exact query. And so we got two search results, one from the vector search and another from the BM25 keyword search. We fuse both the results from both the searches, that is vector search and BM25 keyword search, using the reciprocal rank fusion algorithm. uh, and after that we have applied a cross encoder re-ranker to get the top k chunks from the fuse list. And then we have fetch and deduplicated the parent chunks, because the searching either the because the searching, that is vector search and BM25 search, only happens on the child chunks, not the parent chunks are only for the context purposes. So we fetch and deduplicate the parent chunks and pass context as a parent chunk, in which we have all the page number, section name, chapter name, all the citation things, and the context of the full chunk, and the specific child chunk in which we got our results to the LLM, and then we constructed our final answer. So that's the overall architecture of our rack system. And till now we have implemented that much of rack system. This is our repository from which you can locally um, try our code base and get the submission.csv file which you have uh, requested in the problem statement PDF. This is our submission.csv file which we have generated now, and this kind of look like this, where we have the query number, the answer of that question, and the citation from which we have covered, that is chapter name, section title, section name, and other sources. From all the sources we have got the answer is written in this submission.csv file. And this is the version 1 of our RAG module. We are planning to build a complete CLI based and a web based RAG system. Thank you.